Alright guys, so our last video that we're looking into for 3.7 and implicit differentiation is implicitly differentiating of higher order derivatives. So as you can see here, we're looking to find the second derivative, and we know this as just simply y double prime in the end. And so you're going to see here, I'm going to make a little symbolic change from what we've been doing a little bit differently with implicit differentiation, but it's going to be the same thing in the end. So let's start with what we know. Finding second order derivative, we have to find the first derivative first. So let's find that first order derivative of the following function. So doing so, on the left-hand side, we get 6x squared. 3 times 2 in this example, once again, will give us 6. And this is going to be dy dx, and that equals 0 on the right-hand side. So what I'm going to do is to make a quick little change, all right? I'm going to turn dy dx into just a y prime. We know it means the exact same thing. dy dx is y prime, but because substitution is going to be involved later on, I think it's going to be easier to see using y prime and y double prime versus dy dx. So I'm going to make a quick little switch and just say this is 6x squared minus 6y times y prime equals 0. And now we're just going to solve for y prime. So we get that negative 6y times y prime equals negative 6x squared after subtracting it over. And then dividing through, we get negative 6x squared over negative 6y. Well, those negative 6's are going to cancel out. And then y prime has now a value of x squared over y. Keep that in mind as we continue to move along. Remember, the question wanted the second derivative. I mean, think about it. You just found y prime, the first derivative. Nothing really changes in terms of our concept of the second derivative. Now we're just going to be taking the derivative of x squared over y, which just means instead of doing it like we used to in the past, it's just going to be incorporating implicit differentiation and keeping that y prime or the dy dx involved in the equation itself. So let's take a look. So if I wanted to now find y double prime, well, y double prime is going to be our derivative of our quotient. So don't forget our quotient rule. Quotient rule is b times u prime minus u times v prime over v squared. Well, in this case, we have the derivative of u prime, which is 2x, and then times y, minus x squared, times the derivative of y. Well, derivative of y, remember, is just y prime, or dy dx. I'm going to keep it as y prime, because you'll see why in just a sec. And then v squared is y squared. Well, think about what's in that equation. Now we see 2xy minus x squared times y prime. Well, it wouldn't really make sense to solve for y prime because we've already done it. We already have a value for y prime. So instead, we're not going to solve for it, we're going to substitute what we know y prime to be in for y prime. So let's take a look. This is now going to become 2xy minus x squared times x squared over y, still all over y squared. So what I'm going to do, I'm just going to separate this a little bit. So if we know correctly, this is the same thing as 2xy over y squared minus x squared times x squared over y over y squared as well. Just separated the fraction out a little bit. Well, now here the y's are going to cancel. And so when this is all said and done, we can simplify this coming out to be, let me change colors kind of as we wrap things up. We have 2x over y minus x to the fourth over y cubed, because there was the y in our denominator here and 2 y's in our denominator here, so together they make y cubed. And the only thing that we have to make sure that we say is that y cannot be 0 so that it fits into our specific restriction. Alright? Alright guys, so if you will try 1 on your own just to give it a shot. Alright, ladies and gentlemen, if you will give this one a shot on your own as we wrap some things on up in implicit differentiation, and we'll look at it first thing in on tomorrow. And have a great one, guys.